inside of our cell to maintain resting state, something around negative 70 millivolts charge. Put more potassiums in here. That negative 70 millivolts now becomes negative 90, negative 100. You might recall this is what we call hyperpolarization. And what happens with hyperpolarization?
Harder to reach threshold.
Exactly, harder to reach threshold, so your heart will then slow down the heart rate. So you'll notice here with hyperkalemia, it lowers the resting potential. You might want to make a note. Lowering the resting potential means the interior of your cell now becomes more negative.
Can you repeat that?
Sure. So when it says there lowers the resting potential, we mean the resting state now becomes more negative. So instead of, say, negative 70 millivolts, which is normal resting state, we might be looking at something like negative 90, negative 100. And if you make that interior so negative, your heart can't reach threshold, and you can promote something like heart block or cardiac arrest. Does that help answer your question? Okay. How about any other questions on that page?
Do you have all that information on the D2L printout thing?
I added this morning.
Okay.
If you want these, I can put them up there for you.
I think it's the glance. I
Okay.
was looking through the book and couldn't find them.
And I'll put these two up there for you.
Okay.
I had asked y'all to read over page 51 with heart attack and angina. Did you have any questions after reading through that material? Do you know what the bottom line difference is between a heart attack and angina? Time. Yeah. Which one of those two conditions results from a long-term loss of oxygen? Heart attack, yeah. MI, myocardial infarction, or heart attack is a long-term loss of oxygen. Angina is a short-term loss of oxygen. Going back to thinking about how muscles operate, back from 5-2-10 again, you might have heard of something called oxygen debt, and then of course muscle fatigue. These are the same kinds of concepts again, because if you deprive a muscle of oxygen, you can actually promote the muscle to cramp. The problem with heart muscle, it's amitotic, so if you damage it, what does that mean for your chances of repair?
Not going to happen.
Not going to happen. Instead of repairing that cardiac muscle tissue that dies from a lack of oxygen, scar tissue, which is full of collagen fibers, invades that area. It's fibrous tissue that replaces that cardiac muscle. Cardiac muscle is meant to be stretchy like a rubber band. Collagen fibers are not stretchy, so there's your problem with the contractility and your ability to pump the blood out of the heart. So that's the long-term concern there for something like MI. The very bottom of the page, you might have noticed we had two types of bypasses in fetal circulation, and just briefly want to mention those to you. Before a fetus is birthed, there are two bypasses that prevent blood from traveling thoroughly into the lungs. Now, this doesn't mean the lungs get absolutely no blood. They are getting some blood, but they're not getting blood like an adult is getting. So you'll notice in the heart, between the right and the left atrium, there's a little hole between those two atria, known as the what? Foramen ovale, right. Upon birth, that foramen ovale should close, but there's a remnant of that little hole. What do we call it after birth? Spathovalus, good. In people who have a persistently open container between left and right atria, we call that a PFO. It's patent foramen ovale, and that can actually throw clots to the brain, because instead of pumping blood right atrium, right ventricle to the lungs, back into the left atrium, left ventricle, you've got this leakage between the left and right atrium. Have you heard of Brett Michaels and his heart surgery and all that stuff that's been going on? That's what he had with PFO. It was something where he had a hole in the heart. It threw a clot to his brain. He had the cerebral hemorrhage, I think it was sometime last year. So that's a very serious concern, because the PFO can actually throw clots to the brain. There's another shunt that bypasses the lungs during fetal development time, and that's called the ductus arteriosum. After birth, it's called the ligamentum arteriosum. And what does that connect?
Pulmonary trunk.
Good, pulmonary trunk and aorta. So you'll notice what these shunts are doing is, in a fetus, they're bypassing the lungs. From the right atrium, we pass directly over to the right or the left atrium instead of going down into the right ventricle. Get those words out. That bypasses this chamber, taking blood over to the pulmonary trunk and to the lungs. In an adult, of course, we do want the lungs to be involved for gas exchange, but in a fetus, where is that gas exchange coming from? The mother, through the placenta. The second shunt here, the ductus arteriosus, like you said, it is a connector between the pulmonary trunk and the aorta, and that also helps to bypass the lungs, carrying the blood directly from the pulmonary trunk straight into the aorta. And again, that bypasses blood going over to the lungs for gas exchange. The lungs do need blood for development. There is some blood going to the lungs, but not full-fledged like what we have in an air-breathing person. So after birth, that is also supposed to close. The ductus arteriosus becomes a ligamentum arteriosum, and on those heart models, you might have noticed a little white piece connecting the pulmonary trunk and aorta, and that's supposed to be a remnant of that ductus arteriosus. This can also remain open after birth, and instead of calling it a PFO, this time we call it a PDA, patent ductus arteriosus. So it can also remain open, causing problems for blood flow. Any questions on page 51?
Let's talk about number 3 at the bottom.
Okay.
The creatine. Or creatine.
The creatine kinase. Number 3 at the bottom says, why is a blood test for creatine kinase perhaps not the best one to confirm a heart attack? Okay, let's go back up to the top of the page. Under MI, where it says diagnosis, let's talk about those two things there for just a moment. Creatine kinase, you'll notice there it says it indicates muscle damage. Let's say that you went to the gym, this is your first night working out, and you worked like a mother. You did the treadmill, you rode the bike, you lifted weights, you went home sore, you could hardly move. Okay? If we tested your blood, you would probably have elevated levels of creatine kinase. Okay? If you had chest pains and walked into the hospital and they tested your blood, they would show you had elevated levels of creatine kinase. What if you didn't tell them you went last night and worked out really hard at the gym? What might they think is wrong with you?
You have angina or heart failure.
You might be having angina or a heart attack, and so they may start treating you for a heart attack. But if you said, hey, wait a minute, I spent 2 hours last night really working out hard at the gym. I really don't normally work out, but I worked really hard and I caused my body to push to the limit. Then they say, oh, okay, that may indicate that your skeletal muscles were ripped and torn and damaged, and it may just be your skeletal muscles causing the problem and not your heart actually causing the problem. You'll notice the other thing listed there, creatine, troponin. Troponin, I know you've heard of that, right? Let's go back real quick.
So it would be better to test for troponin.
Exactly. Troponin is part of that complex, and for heart muscle damage, we want to test for creatine troponin. That more specifically indicates heart damage than creatine kinase. Hey, if we test your blood and you're high for creatine kinase, it simply means muscle damage, period.
You can take supplements for that too.
What's that?
You can take supplements for that too.
You sure can. You can take that creatine stuff and make the blood elevated levels come up from that. So yeah, you may not have muscle damage, you may have a supplement in your system. So the troponin stuff there is actually what's more indicative of a heart problem.
Also, the EKG,
Sure, that would be something.